This is 10-7, work and distance problems. All right, we're going to take a look at this formula for a minute, and then we're going to put it on hold and we're going to come back. So let's look at if I do one job and it takes me 5 hours, my rate of work would be one job per every 5 hours. So if I multiply that work rate times the amount of time that I do, you can see how I can get one job. If I use my dimensional analysis, put this all over 1, my 5's cancel out, my hours cancel out, and what I'm left with is one job. Okay? Now, I want you to think about this. I'm going to put it on hold. I'm going to show you an easier way to do some work problems, and we're going to eventually use this formula. Work rate times time equals work done. All right. This also means, just really quickly, which you're not seeing because I'm taping in HD, it's cutting off part of the screen. What this also means is that I can do 1/5 of the job per hour. 1/5 of the job per hour. All right, so now let's go back. I'm going to show you a little bit easier way because this is a basic work problem. Nothing's unique, so I think this method is kind of easier. And here's the formula you're going to use. Job over time plus job over time is equal to job over time. All right. Now, what I mean is I'm going to do some work, my friend's going to do some work. My friend does work, I do work. But if we do the same work in the same room, it should take us less time. So that's what we're trying to figure out here. So this says Jeff can paint a room in 4 hours. One job in 4 hours. And it takes Hal 5 hours to do. So Hal can do one job in 5 hours. Together, they can complete one job. How long will it take them if they work together in an unknown amount of time? So that's it. It's pretty easy. So now I'm going to, there's my equation. I'm going to clear my denominator, multiply by the least common denominator, and cross cancel. I'm left with 5x plus 4x equals 20. I get this as 9x equals 20. Oops, sorry about that. Equals 20. Divide by 9, divide by 9. And I know in algebra a lot we leave it in improper, but this is a word problem. You need to make sense of it. I don't know what 29th time is. So turn that into a mixed number. So when I divide 9 into 20, I get 2 full times. I have a remainder of 2, and I put it over 9. So what this means is they will work together for 2 2/9 hours. Now another thing I want to just mention is 2 2/9 is the same as 2.2 repeated. We also don't say 2.2 repeated hours. So in this case, we really wouldn't want to use the decimal. Pause the recording if you need to write these notes. All right. If you're using the other formula, well, let's move on. No, let's do it now. If you're using the other formula, you get your work rate times the time, the combined time, is equal to the work done. So for Jeff, he's painting one job. He does one job in 4 hours. Hal does one job in 5 hours. The combined time is unknown for Jeff, and the combined time is unknown for Hal. So I place x's. Now I multiply across, and I get 1/4 x, 1/5 x, and then what happens is when I take Jeff's time and I add it to Hal's time for work done, I get one completed job. And you can use that equation as well. Again, we're doing the same thing, multiplying by the common denominator, 20. We basically end up with the same thing. 9x equals 20. Divide by 9, divide by 9. X is equal to 2 and 2/9. Sorry, it's supposed to be a 9. Hours for them to do it combined. All right, so again, let's try one more. Why don't you pause it and see if you can do this one on your own. Now check your work. If you chose to use the job over time method, job over time plus job over time equals job over time. All right, one water hose can fill a pool. I'm going to do one in 6 hours. Oh, sorry, it says 10 hours. And a different hose fills the same pool, 1 in 6 hours. Together, we can complete one job in an unknown amount of time. Multiply by 60x. I'm left with 6x. I'm left with 10x. And here, I'm left with 60. So I get 16x equals 60. Divide both sides by 16. And x is equal to 16 goes 3 full times. And I'm left, that goes 40 into it, 48. I subtract, I'm left with a 12. Add a 16, so this makes 3 3/4. So if I used both hoses at the same time, it would take only 3 3/4 hours. Pause the recording if you need to write the notes. All right, if I'm using the work rate problem with the work rate times time equals the work done, I'm comparing a 10-hour hose to a 6-hour hose. So the first one's going to be one job in 10 hours. The next one's going to be one job in 6 hours. Excuse me. The combined time is unknown for both of them. So my work done for the 10-hour hose is 1/10 x. When I add it to the work done for the 6-hour hose, it's 1/6 x. And together, when I add those up for work done, I complete one job. And there's your equation. Now they're choosing to clear by 30. I use 60. I used a common denominator. They're using a least common denominator. It will still work out. It just meant my reducing, there were bigger numbers when I had to reduce in the end. So as you see, I can clear, I'm left with 3x plus 5x equals 30. So that makes 8x equals 30. Divide by 8, divide by 8. X is equal to 3. I have a remainder of 6 over 8, and that reduces to 3/4. Okay, hours. So it's the same thing. All right, here's where it gets a little bit trickier. Let's read the question. John can tile a room in 80 minutes. It takes Sam 2 hours. If John works alone for 30 minutes and then Sam helps him finish, how much longer will the job take? Now, the uniqueness of this problem comes with a couple different issues. Number one, you have different rates, minutes and hours. And number two, John's working alone for 30 minutes, and then like I get to the job site at 8 o'clock, and then my friend comes at 8:30, and so from 8 to 8:30 I'm working, and then from 8:30 on we're both working. So that's kind of the situation that's happening here. And this is where I really kind of like to use the work rate times combined time. Okay, so I know that John, first of all, I'm going to have to convert that to hours. So I'm going to have work rate times combined time equals my work done. And then I've got John and Sam. Okay, so Sam's time's going to have to be converted from 2 hours to minutes. It's easier to do hours to minutes versus minutes to hours. Excuse me. All right, so let's convert his 2 hours to our minutes, because that's the easier one to do. So that would be 120 minutes. Now, John can do one job in 80 minutes. Sam can do one job in 120 minutes. The combined time, we don't know what it is. But what do we know about John? What else does he do? We know they both work together for a certain amount of time. Let's say that unknown amount of time is X. But John does something a little bit different. So they both work for X amount of time, but John works for 30 minutes longer. So how am I going to show that? With a plus 30. So now what we've got is John's time, multiply across Sam's time, and then add them going up and down to complete one complete job. And there's your equation. Now I'm going to skip forward a little bit. Okay, here's the equation. Now for you guys, I think it might be a little bit easier if you distribute first and then clear. So in this case, we're going to do, so we get 1/80th x plus, I can divide by 10, 3/8 plus 1/120th x equals 1. Now to clear the denominator, we're going to have to multiply by 2. Least common denominator would be 240. I'm starting with the 120. 120, all three don't go into. But when I double 120, 240, they all three go into it. So that's how I chose 240. So now what I get is a 3x plus, this goes 30 times. When I cancel it out, 30 times 3 is 90 plus 2x equals 240. Combine my like terms, 5x plus 90 equals 240. Subtract 90. I'm left with 5x equals 150. Divide by 5. And x is equal to 30. Now what does that mean? 30 what? I know it's minutes, but what does it mean in the sentence? It means the question is, how much longer will the job take? Once Sam joins John, it will take 30 more minutes to finish the job. Pause the recording if you need to write these steps. All right, so now you've tried one with some irregularities. Now you try and do the next one on your own. Now we'll read it together and then you try it. Julie can complete a wedding cake in 8 hours. Marty can put one together in 10 hours. If Julie and Marty work together for 4 whole hours, how long will it take Julie to finish the job alone? All right, so in this situation, they're working together and then Marty has to leave. How much longer is it going to take Julie after Marty finishes? So start your box method, set it up, and see if you can do it on your own. Pause the recording and try it again. Try it on your own. Now check your work. All right, we've got work done times the work rate times the time equals work done. Now remember, this is just kind of like, it's the same thing as your distance, rate, and time. It's rate times time equals your distance, but this one's work rate times time is work done. And here we have Julie and Marty. So Julie's rate is 1 job in 8 hours. Marty's rate is 1 job in 10 hours. The time for both of them is a 4 because they both work 4 hours. Except Julie works an unknown amount of time after that. So how are we going to show that? With a plus x. And Marty's just going to be 4. Now, the work done is Julie's is 1/8 times the quantity of 4 plus x. Marty is 4/10. And I multiply across. Now I add those up, going up and down, and what I get is 1 complete job. So the equation is 1/8 times the quantity of 4 plus x plus 4/10 equals 1. Now, these guys are distributing first. I mean, they're clearing first. I want to show you how they do that. I want you to think about this. When I distribute to all terms. Now, the problem here is that a lot of kids don't realize this is one term. This is another term. And this is a third term. So that's all terms in the equation. Now, this is one term because it's a number times a number. 1/8 times a binomial. That's one term. Then it's separated by that plus sign. That means the next term has started. Since the first plus sign inside the 4 and the x is inside the parentheses, it means that's one term. So I only distribute once here. And when I do that, what I get is 5 times the quantity of 4 plus x. When I distribute here, I end up with, actually I'm going to switch colors. So let's do, left with 5 times the quantity of 4 plus x. It's the first one. Doing it again. 10 goes into 10 once and into 40. Let's say 4 times. 4 plus 4 times 4 is 16 equals 40. Now I distribute, I get 20 plus 5x plus 16 equals 40. 5x plus 36 equals 40. Subtract 36, and we're left with 5x is equal to 4. I'm going to continue up here. 5x is equal to 4. Divide by 5, divide by 5, and x is equal to 4/5. Now what does that mean? What does that mean? How long will it take Julie to finish the job alone? Okay, so if we were working in hours, that means 4/5 of 1 hour. 4/5 of an hour. So I could, by rights, do turn that into a decimal, multiply it by 1, and what I get is 8/10 of an hour. 8/10 of an hour. If I want to come, I think that's okay. You can. So if I divide that, I get x equals 0 and 8/10 of an hour. Pause the recording and write the notes if you need to. All right. Now, if you're not clearing first, I'm just going to ignore that because I can't get rid of it right now. If you're not clearing first, we'll pretend this isn't here. We'll just do our distributing if that's easier for you. So what I get is this divides 8 goes into 8. 4 goes into 8. 4 goes into 4 once and into 8 2 times. So what I get is 1/2 plus 1/8 x plus 4/10 equals 1. And then I have to clear my denominator. I need a number that's going to go into all fours, so I'm going to choose 40. What I get is 20 plus 5x plus 4 times 4 is 16 equals 40. So we get, again, 5x plus 16 equals 40. Subtract 16. I'm doing something wrong here. Subtract 16. We're left with, there we go. I forgot to. Let's go back a minute. To combine my like terms. There we go. So I get 5x plus 36 equals 40. Subtract 36, and we're left with 5x equals 4. Divide by 5, and x is equal to 4/5 of an hour for Julie to keep doing that. Or, the other thing is if you also want to convert the minutes, figure 4/5 of 60 minutes. You can multiply that out, or 8/10 of 60. So if I want to find out exactly how many more minutes, I can take, let's do 4/5 times 60. I know that 5 goes into 5 once. 12 times 4 is 48 minutes. So it's 48 minutes, or 4/5 of an hour. All right, distance problem. You should be somewhat familiar with this, so it shouldn't be that much more difficult. So here's where we have 2 planes going in the same direction. 2 planes leave Chicago at the same time, sorry. One's going westbound, the other's going eastbound. So one's going in this direction, eastbound, the other's going, one's going westbound, one's going eastbound. So the westbound is traveling 900 miles. The other one's going 1,200 miles. Okay, we know that. We don't know their speeds. We don't know their time. But what we do know is it says the eastbound plane goes 150 miles faster and travels 1,200 miles. So we know that this is going faster by 150. This one's unknown. Now, one thing it's leaving out, it's implied, but it's not written. Okay? We know that we've mentioned distance. We know that we've mentioned speed. What is it leaving out? It's leaving out time. And what this question is actually implying is that the eastbound plane goes 150 miles. They're both leaving at the same time. They're both traveling. When does this one get to this destination and this to this destination? At their various speeds. Their time is the same. So that's what it's leaving out. It's implying it, but it's leaving out. So we have rate times time equals distance. I have a westbound plane and an eastbound plane. I like to fill in what I know first. I know for sure the west is going 900. I know for sure the east is going 1,200. Now, speed. Do we know their speed? Both unknown, so let's call them R. The difference is one of those is going a little bit faster than the other by 150 miles per hour. So we'll say the eastbound will be plus 150. Now, what do we know about the time? They're the same. So now what I have are two different equations. Rate times time equals 900. The other one is time times r plus 150 equals 1200. Okay? Now the one thing I know about both of those equations is they have something that's all alone. So I'm going to solve to get that t all by itself. So in the first equation, I'm going to divide both sides by r. What I'm left with is t equals 900 over r. The second equation, I'm left with, I'm going to divide by r plus 150. R plus 150. And what I'm left with is t equals 1200 over r plus 150. So now what I have is something I can go back to chapter 8 and use one of the methods that we learned there. I'm going to take if t is equal to 900 over r and t equals 1200 over r plus 50, then I just substitute in. Solve using substitution. And there's my equation. And the equation is 900 over r is equal to 1200 over r plus 150. Okay, now I'm going to cross multiply. I end up with 900 times r plus 150 equals 1200 r. I don't really have a lot of room here, so I guess I'll bring it down here. 900 times r plus 150 equals 1200 r. Distribute, I'm going to get 900 r. I'm going to erase this top portion here so I have a little bit more room. What I get is 900 r plus 135,000 equals 1200 r. Okay? Subtract both sides, get the r's equal to one side. And we are left with 135,000 equals 300r. Divide by 300, divide by 300, and the answer, r, is equal to 450. Now am I done? Well, that tells me the rate of the westbound train, which is 450, but then I have to also figure out the eastbound, and that would be 450 plus 600. Pause the recording if you need to write these notes. All right, my PowerPoint is a little bit different. I'm going to show it to you. You can choose either method. We're filling in the boxes the same. The thing is, they start right from the beginning. They isolate the distance formula for t. So divide, since they're both the same, we're going to isolate for that. Divide both sides by r, t is equal to distance, and they just set it up. If t equals distance, so t is equal to 900 over r, they just set it up. T is equal to 1200 over r plus 150, and then they just do the straight substitution right away. So that's where they end up with what you're not seeing that's getting cut off is they give you the 900 over r equals 1200 over r plus 150. So that's what you're missing right down here. All right, I'm going to continue it. Cross multiply. We end up with this. Simplify it. And we end up with the same thing, which is for r equals 450. Dividing both sides. Now, remember, all they did was, they subtracted 900 and there we have it. All right, pause the recording and see if you can do the next one on your own. Now check your work. Rate times time equals distance. All right. So Anne leaves school and walks home for 3 7/75 miles. So that would be 3 3/4 miles. So that's our distance. Mark runs home 1.5 miles per hour faster than her. So his rate's going to be r plus that 1.5. Now, he lives 6 miles from home. Okay? Remember, t equals, do our substitution. We're going to get 3.75 over r. You need to see it. I'll write it right up here. Then I'm going to erase it. 3.75 over r equals 6 over r plus 1.5. And now you can go on to the next section, cross multiply, distribute out. You finish, we get r equals 2.5 when I divide that. So if r is 2.5, then Mark is going traveling, if r is 2.5, then Mark is traveling 4 miles per hour. But now we have to go back to the question. If he lives, they both leave and arrive at the same time, how long did it take them? So they want the time this time. So what you have to do is just substitute in for either of the distance, rate, and time formulas. So they're doing it to the first one, Anne, right? So we're going to take the first equation, Anne, right here, rate times time equals this, and that's where we're getting this equation. Substitute in, divide by 2 5/10, and that's where we get the time is 1.5 hours. Oops. So stop for a minute if you need to. What you're missing right down here is just the cross multiply, the substituting in at the bottom. All right, last problem. I didn't go through this at school. The reciprocal of 4 less than x. So how would I show 4 less than x? 4 less than x, because we have a than. What would the reciprocal of that be? If that's the normal, remember any number over 1, the reciprocal would be 1 over x minus 4 is equals 3 times the reciprocal of x. 3 times 1 over x. Okay? And then we're going to make that 3 over x. Now, remember your restrictions here. So x is not allowed to equal 0, and x is not allowed to equal 4. We're going to multiply by a common denominator. Oh, you know what? Actually, it's probably easier. Sorry. We're going to cross multiply. It's cross products. We get, subtract 3x from both sides. We get x is equal to 6. So divide that out. And so, does that work for both denominators? Yes. So, there is the answer. And that's the lesson.